Our planet, billions of years ago. It is a world almost entirely of water. The continents we know are unformed. The land is silent stone, baked by a young sun. There are no sounds, no birdsong, no rustling leaves, but beneath the surface of the vast global ocean, something truly extraordinary is stirring. Life has begun. It started as the simplest of cells. For an immense stretch of time, these tiny organisms were all there was. They drifted in the currents, slowly, imperceptibly changing. It is a story so grand, it's hard to grasp. It is the story of us all. These early life forms were simple animals. Think of them as soft-bodied jellies or strange, segmented worms. They swam and crawled across the seabed. The ocean provided everything they needed. The water supported their bodies, so they did not need strong skeletons. It brought them food. It carried away their waste. It was a perfect, self-contained nursery. For hundreds of millions of years, the land remained utterly barren, an empty stage waiting for the players to arrive. The oceans were teeming with an ever-growing variety of creatures. The ocean was crowded. It was a world of fierce competition. Every niche was filled. But at the water's edge, a new opportunity was emerging. Mosses, ferns. They offered a new source of food. They created a new habitat. For the animals brave enough to venture out, the land was a world of promise. The journey was about to begin. The pioneers of this new world were not mighty beasts. They were fish, but a special kind of fish. They lived in the shallows, swamps, river deltas, places where the water was often low in oxygen and could even disappear during a dry season. These were the lobed-finned fishes. Unlike other fish, they had fleshy, bone-supported fins, sturdy, muscular paddles. These were the precursors to legs. They could push against mud, prop their bodies up in shallow water. These fish also had another critical adaptation, a primitive lung, a simple air sac connected to the throat. It let them gulp air from the surface when water was foul. This was their lifeline. In drying ponds, others suffocated, these breathed. That ability to breathe air, even briefly, unlocked the land. A fish was breathing air, as you and I do now. The connection is direct and unbroken. Think of Tiktaalik, found in the Canadian Arctic. It lived some 375 million years ago. It had the gills, scales, and fins of a fish, but also a flattened skull and a mobile neck. Its front fins showed beginnings of a wrist and finger-like bones. It could do a push-up, perfect for life in the shallows. Not a land animal yet, but no longer just a fish, the perfect intermediate. From these beginnings came the first true tetrapods, creatures like Ichthyostega, Acanthostega, well-formed legs with distinct toes, still tied to water, skin not waterproof, eggs laid in ponds. But they could walk on land, move between bodies of water, the first vertebrates to feel solid earth beneath their feet. Ancestors of every amphibian, reptile, bird, and mammal that has ever lived. That first clumsy step was a giant leap for animal kind. Conquering the land required a complete re-engineering of the animal body. It was not simply a matter of walking out of the water. Life on land presented a host of new and formidable challenges. The most immediate was gravity. In water, buoyancy supports an animal's weight. On land, gravity is a relentless, crushing force. A strong internal skeleton became essential. Backbones had to become more rigid. Limb bones needed to be robust. Strong muscles developed to lift the body and power movement. The fin became a foot. The paddle became a pillar. Breathing was the next great hurdle. Gills are marvels for extracting oxygen from water, but in the air, they collapse and dry out, becoming useless. The simple lungs of those early fish had to become more complex. They developed vast, folded internal surfaces. This is the design we see in our own lungs. A huge surface area, packed into a small space, allows for the efficient exchange of oxygen into the blood. This new, powerful engine would fuel the active lifestyles of terrestrial animals, from the slow crawl of a tortoise to the swift sprint of a cheetah. Then there was the problem of water. The very substance that had nurtured life for billions of years was now a precious resource that could be easily lost. An animal on land is constantly at risk of drying out. Skin had to change. The moist, permeable skin of a fish or an early amphibian gave way to new, more resilient coverings. Reptiles developed a layer of dry, overlapping scales, a waterproof barrier dramatically reducing water loss, allowing them to venture deep into the arid interiors of the continents. Finally, the senses had to adapt. Vision works differently in air than in water. The eye had to be refocused. A protective eyelid evolved to keep the eye moist and clean it of debris. Hearing, too, was transformed. Sound travels differently through the thin medium of air. Small bones in the skull, which had once been part of the jaw support in fish, were repurposed. They became a system of levers to amplify airborne vibrations and transmit them to the inner ear. A new world of sound opened up. The land was no longer silent. For the early land dwellers like amphibians, one tie remained unbreakable. They had to return to the water to reproduce. Their eggs were soft, jelly-like spheres. They had no protection against drying out. Tadpoles hatched fully aquatic, breathing through gills. This dependence on water limited where amphibians could live, tethered to ponds, streams, damp forests. To conquer the land, animals had to solve reproduction. They had to bring the pond with them. The solution: the amniotic egg. It first appeared in early reptiles, a private, self-contained nursery. A porous but protective shell allowed gas exchange. Inside, membranes surrounded the embryo. The amnion held the embryo in fluid, a miniature ocean. Another sac collected wastes. The yolk provided food, a complete life support system. This egg changed everything. For the first time, vertebrates could lay eggs on dry land. They were free from the frantic rush to the nearest pond, free to explore and colonize new, drier habitats far from any open water. That freedom sparked a reptile explosion. They spread across Pangaea, adapted to forests, deserts, plains, dominant for over 150 million years, the age of reptiles. All thanks to that innovation. Later groups refined it. Birds perfected a hard, calcified shell and evolved incubation behavior. Mammals took a different path. A few, like the platypus, still lay eggs, but most retained the egg inside the mother's body. The placenta took over egg functions, nourishing the embryo directly. After birth, milk provided the perfect food source. Internal development and parental care gave mammals an extraordinary advantage, helping them to survive and thrive. Once the fundamental problems of life on land were solved, a spectacular radiation of animal life began. Animals moved out from the warm, wet coastal regions to claim every corner of the globe. Natural selection was the driving force. In each new environment, small, random variations in a population would be tested. Individuals with traits that gave them even a slight edge in survival or reproduction would be more successful. Over immense spans of time, these small advantages accumulated, producing entirely new species, exquisitely adapted to their ways of life. Consider the diverse landscapes of our world. In the scorching heat of the desert, reptiles and mammals evolved ways to conserve water. Some became nocturnal, avoiding the brutal sun. Others, like the camel, developed an incredible capacity to endure dehydration. In the freezing polar regions, a different set of challenges arose. Thick layers of fat provided insulation. Dense coats of fur and even feathers kept in heat. The polar bear, with its white coat and huge, snowshoe-like paws, is a master of this icy realm. Each extreme environment shaped its inhabitants. The air itself became a new frontier. Insects were the first to take to the skies over 300 million years ago. Their wings opened up new worlds for finding food, escaping predators, traveling vast distances. The flying reptiles, the pterosaurs, soared on wings of skin. Then came the birds, whose feathered wings allowed for powered, agile flight. And finally, mammals produced their own aviators, the bats, who navigate and hunt in total darkness using sound. Each conquest of the air was an independent evolutionary marvel. Some animals even returned to the water. The ancestors of whales and dolphins were four-legged land mammals, something like a small hippopotamus. Over millions of years, they became increasingly adapted to an aquatic life. Their front legs transformed into flippers. Their back legs disappeared. Their nostrils migrated to the top of their heads to become a blowhole. Evolution is not a one-way street. It is a branching, exploratory process, always finding new ways for life to flourish, even if it means returning to the world that was first left behind. When we look at the incredible diversity of animal life on Earth today, we are looking at the results of this epic 400 million year journey. When we look at the incredible diversity of animal life on Earth today, we are looking at the results of this epic 400 million year journey. From the smallest shrew to the largest blue whale, every land animal, including ourselves, carries the legacy of those first pioneers. The fundamental blueprint of our bodies was forged in that transition from water to land. Our four limbs are modified fins. The air we breathe fills lungs that first evolved in a muddy swamp. The tiny bones in our middle ear were once part of a fish's jaw. We are walking, talking archives of natural history. This long story of adaptation and survival shows the astonishing resilience of life. It has endured mass extinctions, ice ages, and dramatic shifts in climate. In the face of every challenge, life has found a way, diversifying into new forms to fill the available niches. This capacity for change is a source of great hope. However, we are now part of this story in a new and powerful way. Human activity is changing the planet faster than ever before. We are altering habitats, changing the climate, and putting immense pressure on the very processes of adaptation that created the world we know. Understanding the deep history of how animals conquered the Earth gives us a vital perspective. It shows us how interconnected life is. It teaches us that every species is a unique solution to the problem of living, the result of an unbroken chain stretching back millions of years. The story of life's journey from the sea to the land is ultimately a story of opportunity and hope, showing that from the humblest beginnings, incredible complexity and beauty can arise. Our own future is tied to the health of the planet. By cherishing and protecting this legacy, we ensure the story of life will continue long into the future.